Hello everyone, in this video we will learn all about midline theorems and non-parallelograms. Now to begin with, we have here a midline of a triangle. Now a midline of a triangle is a line segment that joins the midpoints of two sides of a triangle. Now given this triangle ABC, this G and E are midpoints of sides AB and BC. So this line segment GE here is a midline of triangle ABC. Now some properties of a midline of a triangle. Number one, it is parallel to the third side of the triangle. So with this segment GE is parallel to segment AC. Another is, it is half the length of the third side of the triangle. So if this AC here measures X, so this GE measures X over 2. So from here, you can say that GE is a mid-segment of triangle ABC. So it could be a mid-segment or it could be a midline. And GE is parallel to AC. And if AC is given as 8, therefore GE is 4. So take note of that. Now, given this triangle ABC, this DE here is a mid-segment of triangle ABC. Now, if AB here is given as 10 centimeters, it would follow that DE is given as 5 centimeters. Another. Now, given this triangle DEF with line segment or mid-segment 12 for MN, now the value for DF here will be 24. So, double to get the third side. Okay, another. Now, given this triangle ABC with points D, E, and F as its midpoints. Now, if BF here is given as 5 cm, so therefore FC is 5 cm. And DE, which is parallel to BC, is 5 cm as well. Now, if A to E is 7 centimeters, so therefore A to C is 14 centimeters. And DF, which is parallel to AC, is 7 centimeters. Next, if A to D is 4 centimeters, therefore A to B is 8 centimeters. And F to E is 4 centimeters. Now, what about the perimeter of triangle DF and E? So take note, DF is 7, FE is 4, and DE is 5 centimeters. So with that, its perimeter is 16 centimeters. Now, what about the perimeter of the big triangle ABC? So take note, double this is 8. This is 10, and this side here is 14. Adding all that would be 32 centimeters. Now, take note, for a triangle, the perimeter of the triangle formed by the midpoints of its sides is 1/2 of the perimeter of the big triangle. So that's why this is 16, and for the big triangle, it is 32. So take note of that. That works for triangles. Okay, another. Now, given here, triangle XYZ with its midline or midpoint or mid-segment AB. So with this, we can say that AB is 1/2 of XZ. So substituting this one, so this would become 3x minus 1 and half of 34. Now take note, half of 34 is 17. Transferring 1 to the other side, that would become 18. Dividing both sides by 3, so we will end up with 6. Okay, another example. Now, given here, quadrilateral ABCD is a square with F, L, O, and R as midpoints of its sides. Now, if A to C is given as 12 centimeters, what then is the perimeter of F, L, O, and R? Now, take note, A to C is 12. Now, this diagonal here divides the square into two congruent triangles. So, in here, triangle ABC, LO is a midline or a mid-segment of this triangle upper, and FR is also a mid-segment of triangle ADC. So with this, LO is congruent to FR. So that would be 1/2 of AC or half of 12, so therefore it's 6. Now the same thing if we will draw a diagonal connecting B to D. So with that, RO is also congruent to FL, which is half of 12, so therefore it's also 6. Now, getting the perimeter of quadrilateral FLO and R, so that would simply mean adding all of these blue sides here. So that would be 4 times 6, or that is 24 centimeters. So take note of that. Now, let's have the sample geometric proofs for midline or mid-segments. Now, given this triangle ABC here, G is the midpoint of segment AB and E is the midpoint of segment BC. Now, prove that GE, or this segment, is parallel to AC, and at the same time, it is indeed 1/2 of AC. So, take note, before we prove, we should know our definitions, theorems, and properties. Next, we should label the drawing. Next, we should know where we are going, in which that's what is required in the problem. And of course, number 4, the given is given for a reason. So starting with this, in array, opposed to G to E, so opposite to that would be N to E. So there is a point in N here in which GE is congruent or equal to EN, because in array, there is exactly one endpoint of a given distance from the endpoint of the ray. So marking, we will have GEN equal to EN. So take note, G is the midpoint of AB and E is the midpoint of BC. So that's our given. And this is also our basis for the third statement. So if this is a midpoint, it would follow that AG is congruent to BG and BE is also congruent to CE. That's definition of midpoint. So marking this, we will get this one. Next, now take note of this. Angles 1 and 2 are vertical angles, so therefore they're congruent. So vertical angle theorem. So with this, we have proven that. So marking, we will get this. So triangle EGB is congruent to triangle ENC by SAS. That is side angle side of this triangle is equal to the side angle side of this triangle. So therefore, these two triangles here are congruent by SAS triangle congruence. Okay, next. In here, angle 3 is congruent to angle 4 and GB is parallel to CN. So why? It's because all of these are corresponding parts of the two triangles. So it would follow they are congruent by CPCTC, or that's corresponding parts of congruent triangles are congruent. Okay, next. So marking them. So we'll get this. So with this, AB then is parallel to CN. So how come is that? So take note, angle 4 is congruent to angle 3. So if these two sides here are parallel, so these two are congruent. So since they're congruent, it would follow that AB and CN are parallel. That's the converse of the alternate interior property. So take note of that. Okay, so with this, G to A is congruent to C to N. That is by transitive property. So where is this coming from? So take note here, GB is equal to CN and GB here is equal to AG. So it would follow that AG is also equal to CN. That is by transitive property. Okay, next. So with that, we can say that AG and C is a parallelogram. It's because a pair of opposite sides are congruent. That is GA and CN. So with this, if this is a parallelogram, so it would follow that GE is also parallel to AC. It's because opposite sides of a parallelogram are also parallel. So with that, from here, G to N is equal to GE plus EN. So that is by definition of betweenness. So with that, so G to N is equal to GE plus GE, because again, GE and EN are equal. That's stated here. So that would equate to 2GE. So that is by substitution and by addition property. So we simply replace EN here by GE and we simplify. So GE plus GE, that's 2GE. So in here, we can say that GN is congruent to AC. It's because opposite sides of parallelogram are congruent. And another, so replacing this, GN here can be replaced by 2GE is equal to AC. So that's from here. So GN replaced by 2GE is equal to AC. So that is by substitution. And dividing both sides here by 2, so we will end up with GE is basically 1/2 of AC. That is by multiplication property. Now we divide the entire equation in 14 by 2. So indeed, this one prove this one. And it's this GE parallel to AC is also mentioned in item number 10. So take note of that. It's quite long, but as long as you will get through with the process, so you will still get it. Okay, next. Now, another is the parallel lines and the intercept theorem. So it states that if two or more parallel lines intercept at congruent segments, when they intercept congruent segments on every transversal. So given this, A and C here are transversal lines. Line 1, line 2, and line 3 are parallel segments. So in here, if P to Q is congruent to Q to R, it would follow that K to M is also congruent to M to N. So with this, if P to Q is 5, then Q to R is also 5. Now if K to N is 20, M to N then is 10. If Q to R is given as 8, so Q to R, so with that P to R, that would be 16. And P to Q is 8, so adding them, you'll get 24. Next, if K to M is equal to 3x plus 7, and M to N is 2x plus 11, find x and Km. So take note, Km and Mn are equal. So with that, we substitute. So transferring x to the other side, 2x, so that would become x, and 11 minus 7, that would become 4. So with this, our x is 4, and to get Km, that's simply 3 times 4 plus 7, or that would become 19. 3 times 4 is 12 plus 7, that's 19. So Km is 19. Okay, another example. Now we have here quadrilateral E, F, G, and H with EF parallel to BC, parallel to AD, and parallel to HG. Now, if E to B is equal to B to A is equal to A to H, and that's 12, and C to D is 10, what then is F to D and G to F? So take note here, F to D is basically FC plus CD, or basically that's twice of CD. So with that, that would become 20 cm. Now what about G to F? Now G to F is basically 3 times the distance of CD. So that's 3 times 10, or that would be 30 centimeters. Okay, another. Now, if A to B is equal to BE is equal to HA, and F to C is given as x squared plus 2x plus 4, and D to G is 2x squared plus 4x plus 1. So find C to G. Now take note here, D to G is equal to F to C. So these are of equal length. So with that, we substitute. So 2x squared plus 4x and x squared plus 2x plus 4. So simplifying this, so this will become x squared. Transferring 2x here, that will become 2x. And 1 minus 4, that would become negative 3 equals 0. Now at this point, let's factor. So the values for x here could be negative 3 or positive 1. So at this point, we will consider x as negative 3. So finding DG, so substituting will end up with 7. And finding FC, substituting will end up with 7 as well. Now if x is equal to positive 1, so substituting, DG here is still 7, FC is still 7. So with that, to find CG, C to G is basically twice the distance of DG, in which it is 7, so that would become 14. Median of a trapezoid. Now, a median of a trapezoid is a line segment connecting the midpoints of the legs of a trapezoid. Now, given this, ABCD is a trapezoid with segment EF as its median. Now, there are different properties of the median of a trapezoid. Number 1, it is parallel to the bases. So with this, EF is parallel to BC and AD. Another, it is half the sum of the lengths of the two bases. So with that, to solve for EF, you simply add BC and AD and divide it by 2. So, for example, we have here trapezoid ABCD with PQ as its median. Now, if A to B is 10 and C to D is 30, to get PQ, that's simply 10 plus 30 divided by 2, or that would be 20. Now, if the median is 17 and one of the bases is 8, so to do that, that would be PQ is equal to AB plus CD divided by 2. So since our PQ here is 17, so 8 plus CD, so transpose 2 times 17, that's 34 minus 8, or CD is 26. So the same thing here. So double PQ, 37 times 2 minus 41, that would be the length for AB, which is 33. Okay, another. Now, if A to B is 2x plus 10, C to D is 3x plus 20, and PQ here is given as PX, how long is PQ? Now, take note, PQ is AB plus CD divided by 2. Now, substituting, this is 4x, our AB is 2x plus 10, and our CD is 3x plus 20. Now, simplifying, 8 times 2 times 4x, that's 8x, and 2x plus 3x, it's 5x, and 10 plus 20, that would be 30. Transferring 5x to the other side, that would become 3x. Dividing both sides by 3, so our x would become 10. So to solve for PQ, that would simply be 4 times 10, or that is 40. So take note of that. Okay, non-parallelograms. Now, a quadrilaterals in which it's considered as non-parallelogram, it has two sets. It could be a trapezoid or it could be a kite. Now, for a trapezoid, we will focus on an isosceles trapezoid. So to begin with, an isosceles trapezoid is a trapezoid with congruent legs. Now, given this trapezoid A, B, C, and D, this AB here is parallel to CD based on the markings here, and they are considered as the base. Now, this AD here is congruent to BC based on the markings, and they're considered as legs. Then we have here base angles, angle A, angle B, and angle C and D, and they're considered as the base angles. And we have here lines AC and BD, and they're considered as the diagonals. Now, there are different properties of an isosceles trapezoid. Number 1, the base angles are congruent. So with that, angle A is congruent to angle B. Another set is angle D is congruent to angle C. Okay, another. Opposite angles are supplementary angles. So with that, angle A plus angle C, that should sum up to 180 degrees. The same thing with angle B and angle D. Next, diagonals are congruent. So with that, BD is congruent to segment AC. And next, we have a median, which is parallel to the bases, and its length is 1/2 the sum of base 1 and base 2. So let's have an example. Now, given this, an isosceles trapezoid ABCD with its median as EF. Now, if A to D is given as 10 cm, then B to C is also 10 centimeters. Now, if the measure of angle ADC or angle D here is 60 degrees, so therefore the measure of angle C here is also 60 degrees because they are base angles. Now, if this is 60 and 60, so therefore the measure of angle A here is 120 degrees. So take note, opposite angles are supplementary angles. Okay, next. If A to C is 18 meters, so therefore B to D is also 12 meters. Next, if A to B is 8 meters and C to D is 16 meters, so to find EF. So 8 plus 16, that's 24 divided by 2. So that would be 12 meters. Okay, next. If the median here is 9 meters and AB here is 5, so to find CD, so double the median. So 9 times 2, that's 18, minus 5, so that would be 13 meters. Okay, another. Now, if AC here is 5x minus 10 plus 10, and BD here is 6x minus 10, so how long is AC? Now, take note, BD and EC are congruent because they are diagonals of an isosceles trapezoid. Substituting this one, we'll get this, and simplifying, we will get 6x minus 60, 5x minus 50 plus 10. Now, simplifying further, so 6x minus 5x, that's x. So negative 50 plus 10, that's negative 40. So plus 60, so that would be 20. So to find AC, so 6 times 20 minus 10, or that would be 60. Take note of that. Okay, another. Now, we have here a trapezoid ABCD. If the measure of angle ADC is 2x minus 30 and BCD is 3x minus 20 minus 10, so what's the measure of angle A, D, and C? Now, take note here. Angle BCD or angle C and angle D are congruent because they are base angles. So with that, let's substitute and simplify. We'll get 3x minus 60 minus 10 and 2x minus 30. So with this, simplifying further, so negative 60 minus 10, that's negative 70. Transfer to the other side, negative 30 plus 70. So therefore, x is 40 degrees. And to find ADC, that's twice of 40 degrees minus 30. So that would be 50 degrees. Okay, another. Now, if BCD here is 2x minus 5 plus 40, and CBA here is 6x minus 10, what is the measure of angle BAD? Now, take note, BCD plus CBA, when you add them, it should sum up to 180 degrees. Substituting, we'll get this, and simplifying, we'll get 2x minus 10 plus 40 plus 6x minus 10 is 180. Simplifying further, 2x plus 6x, that's 8x. So negative 10 plus 40 minus 10, that's 20. Transfer to the other side, so 120 minus 20, so we'll end up with 160. Dividing both sides by 8, so the value for x is 20 degrees. Now take note, the measure of angle BAD, so this angle A here is equal to the measure of angle B. So substituting, so we'll get 6 times 20 minus 10. So measure of angle BAD is 110 degrees. So take note of that. Okay, next. Now, let's have this geometric proof. Now, take note here. It's given that isosceles trapezoid ROMA. We have to prove that RM is congruent to AO. Now, take note here. I'm giving all the statements. So, we will identify all the reasons. So, for number 1, definitely it's the given. Now, for statement 2, basing on statement 1, so if ROMA is an isosceles trapezoid, it would follow that OR and MA are congruent. It's because legs of an isosceles trapezoid are congruent. Okay, another. Angle ROM is congruent to angle AMO. So take note in here, base angles of isosceles trapezoid are congruent. Okay, another. We have here a statement OM is congruent to OM. Take note, that is by reflexive property. So with that, we can say that ROM is congruent to triangle AMO based on the markings. You have their side, you have an angle, and you have a side. So that would be side, angle, side, triangle congruence. So with that, we can say that RM is congruent to AO, in which these two are parts of the two triangles. So with that, our reason would be congruent parts of congruent triangles are congruent. So take note of that. Okay. Now let's have here another non-parallelogram, which is a kite. Now a kite has two distinct pairs of adjacent congruent sides. Now given this kite, this is a kite A, B, C, and D. And we have here adjacent sides AD and AB, and we also have BC and CD. Now these are the different properties of a kite. Number 1, one diagonal is a perpendicular bisector of the other. So with that, DB is perpendicular to AC. In this case, AC bisects segment BD. So take note of that. Okay, next, its area is half the product of the lengths of its diagonals. So take note, diagonal 1 times diagonal 2 divided by 2, that's its area. Then one pair of opposite angles that are congruent. So with this angle here is congruent to this angle. Take note, AD here is congruent to AB, and CD is also congruent to CB. That is a kite. So let's have this one. Now, given this kite, A, B, C, and D. Now, if A to D is given as 10 units, therefore C to D is also 10 centimeters. If the measure of angle BAD here is 110 degrees, so the measure of angle BCD here is also 110 degrees. And the measure of angle AOB, so take note, they're perpendicular, so that would be 90 degrees. Okay, another. Now, if A to C here is 12 meters, D to O is 8 meters, so therefore, how long is AD? So in here, we can make use, or we can form a right triangle in which you have here AO squared plus DO squared is equal to AD squared. This is a right triangle. So we can make use of the Pythagorean theorem. So with that, substituting, if AC is 12, so therefore AO here is 6 meters. So our DO is 8. So simplifying further, so AD here would become 100. Get the square roots to both sides. So our AD here is 10 meters. Okay, another. Next, here AB is 5 and AC is 8 meters. So BC here is also 5 meters. Take note, AB is congruent to PC. Now, how to find BO? So again, we can form a right triangle here. BO squared plus CO squared is equal to BC squared. So take note, it's still a right triangle. So with that, let's substitute. B to O is unknown. Our CO here is 4 because our AC is 8. And our BC here is given as 5. So simplifying further, so that's 25 minus 16. So getting the square root to both sides. So therefore, our BO here is 3 meters. So take note of that. Okay, another. Now, here, we are given a kite, ABCD. Now, if B to D is x minus 1 feet, and A to C is x plus 2 feet. Now, if the area of this kite is 44 feet squared, how long are BD and AC? Now, take note, formula for the area is diagonal 1, diagonal 2 over 2. So, our diagonals here, x minus 1 and x plus 2, and our area is 44. Simplifying further, we'll get here 2 times 44 is 88. So by FOIL, so this is x squared plus 2x minus x minus 2. So simplifying further, x squared plus x minus 90 is equal to 0. So with that, factoring this, or the values for x is negative 10, positive 9. In this case, we will consider 9. So with that, to find BD, so that would be 9 minus 1, or that would be 8. And to find AC, so that would be 9 plus 2, or that would be 11. So take note, we can always counter check. 8 times 11 is 88 divided by 2. We'll always go back to 44. So take note of that. Okay, let's have this geometric proof. So given here a kite, ABCD. So prove that the area of a kite is indeed 1/2 of AC times BD. So in this case, I'm giving all the reasons, so we will identify all the statements. So take note, given here, so that would be kite ABCD. So take note here, diagonals of a kite are perpendicular. So with that, AC is perpendicular to BD. Okay, next, we have here area addition postulate. Now take note, to get the area of a kite, that would be the area of triangle ABC plus the area of triangle ADC. So take note of that. So area of or formula for area of a triangle. So for triangle ABC, so that would be 1/2 of the base AC and your altitude BE. Then for triangle ADC, so that would be 1/2 of the base, which is AC, and the altitude, which is DE. So with this, let's substitute. So going back to statement 3, so area of a kite here. So take note for triangle ABC, so 1/2 ACBE, and for triangle ADC, so that would be 1/2 AC times DE. So take note here for 6, so referring to the previous statement, take note 1/2 AC is common, so factor it out. So with this, we're left with BE, and for the second term, we're left with DE. Now, definition of betweenness. Now, take note for BD here, diagonal BD, that would simply be BE plus DE. So take note of that. So by substitution, so we have here 1/2 AC. So take note BE plus DE is the same as BD. So with that, indeed, the area of a kite ABCD is 1/2 AC BD, and that is by substitution